So for our experiment, we wanted to measure the output of 3 different muscles, which required us to have 3 separate voltages, 1 for each muscle. So this is why we have 3 different spiker shields. So when you're taking this into the computer, you obviously have to be able to differentiate between the different voltages, right? Because if you combine them all, then, you know, whatever, doesn't matter. So the way you can tell that they're all different is this little, like, plastic piece right here.
On the first 2 things.
I really hate this camera right now. Yes. There we go. First input, or voltage 0. And then we got second input,
second set of
voltage
pins.
1. And then we got third input, which is voltage 2. Alright. So, this is how you assemble all of them. I'm gonna try this. This one goes on top first. So the bottom one is the one that is voltage 0. And you would actually like put all the pins all the way in, but I'm just gonna show you how this goes. Like that, and then you push it down. Here we go. Like that. And then you can see these are all lined up. And everything's lined up. This is how you connect it to the computer. It's just a USB. It's the funky USB, the same kind that is used for the Finches, actually. So the weird one, please focus. The weird one and then the normal one. The weird one goes into this yellow port right here, and then the normal one goes into your computer wherever your USB port is. So PLX is really easy to use once you have it connected. We have installed the proper code onto the Arduino, so if you really shouldn't have to alter the code unless you want to, and you want a different number of, I guess, like outputs, but I guess that also doesn't matter because you could just like ignore these columns in the data table. So how it works is you figure out what port your Arduino is on, and you can do that by going to the control center and looking through devices, and it will show everything that's hooked up to your computer. And this happens to be hooked up to COM3, so you can see right there it says port 3, and all you do is you could click connect, and look at that.
Yeah. Remember to keep the baud at 9600. I think that's a constant, but just remember, if it changes, it's not really going to work that well.
Pro tip, since this PLX records in universal time, or what's the word? Standard time with, like, you know, goes over 12 o'clock, whatever, 24 hours. If you're doing anything that needs to be timed, you can use, pull up a universal clock online and use that as your stopwatch, so that you know when things begin and when things end, because it's really hard to start 2 different programs at the exact same time, like we had to do for the grip strength test. We applied the electrodes to the arm for our experiment. We used the same placement for both grip strength and wrist flexion tests.
So I'm going to put 2 near the wrist, and then 2 on the brachioradialis. 2 on the extensor digitorum, flexing hand. Alright. And then 1 ground electrode goes right on the back of the hand. Alright. And now we'll connect it to the cords. The bottom electrode, if that doesn't happen, the bottom cord, how we did it in our experiment, correlates to the brachioradialis electrodes. So you put both of the red cords, connected them to the electrodes in the corresponding region, and then you put the ground on the back of the hand, which is black. And then you go onto the second cord. Oh man. Oh jeez. This is gonna take a second. I didn't plan for this. Okay. And we are about there. Okay, so you do the same thing, but we designed it so that we're gonna put these on these electrodes up here, and then we again attach the ground electrode or ground cord to the ground electrode, and you can just put them on the sides of the alligator clips, so you don't have to worry about how you're gonna fit all three of them on the tiny little clip. And then the last one, which is the top spiker shield, you again do the same thing, and you attach the red cords to the electrodes of where you want to get the reading, and then the ground cord to the back of the hand. Oh boy. Like that.
So for our experiment, we obviously needed to start at like 0, right? So we had the subject all like rest their hand on the table, and one of the tests that we did was wrist flexion. Flexion is when you decrease the angle of a joint, like, you know, between two bones. So wrist flexion is not like squeezing your hand and like showing your biceps. You have to literally just like flap your wrist over like that. So back to the PLX. What you do is you click connect, and then when I tell my subject here to flex her wrist, and then we go back and look at it. Hopefully we will see some evidence that something changed in the muscle. You can see how it was kind of, it was in the like 80s, 60s, kind of in that range, and then it jumps into the hundreds and even up to 200 for voltage 0, voltage 1, and then for voltage 2 it even got up to, it got up way high to like in the 800s. So you can see that there's clear correlation between the wrist flexion and the data collected through the EMG. So that's experiment. Disassembly is really easy. You basically just very, what's the word?
Hopefully gently.
Methodically,
Oh.
gently remove the alligator clips from the electrodes. But then the electrodes are really sticky, so you just have to rip them off like a band-aid because it's awful. And then everything goes back into its respective box.